This is the chart of Beammwave B, listed in Stockholm, Sweden, with a market cap of 40 million US dollars. They are based in Lund in southern Sweden. The stock price surged in April, attracting retail investors. After the company raised $9.2 million, the stock price crashed as retail investors jumped ship. Recently, the stock price has been recovering. Could this be a multi-bagger opportunity? Quite possibly. Watch this video to the end to find out. And please like this video and subscribe to the channel. The cell tower sends digital information to the phone through a high-frequency carrier wave. Noise can disrupt the digital information. Sources of noise can include other mobile signals, power lines, and temperature gradients in the atmosphere. The signal is duplicated on other frequencies as a backup so that the phone's software can decode the information. More frequencies, in other words, greater bandwidth, speeds up the flow of digital information. In 1948, Claude Shannon derived the maximum capacity theorem, where C is the capacity of data transfer, B is the channel bandwidth, and S is the signal strength, and N is the noise level. The lower frequency 3G has a narrow bandwidth. The bandwidth and frequency increases as we go from 4G, 5G, and 1G to 6G. The 6G has a very high frequency. This partly accounts for the increase in mobile communication speed over the years. We can understand the S divided by N term, which is the signal to noise ratio, through an analogy. We have all been in a noisy environment, perhaps an inconsiderate noisy neighbor who likes to play a musical instrument. The music is the noise, and to be heard, we need to raise our voices, which is the signal. In practice, we do not want to increase the energy use of a mobile phone antenna or cell tower. Instead, we can ensure a strong signal by focusing it in a specific direction. This is known as beamforming. The evolution from 2G to 5G. Low-frequency 2G towers were tall and transmitted a wide beam covering a large area. High-frequency 3G and 4G had less range than 2G, and the signal was concentrated in 3 directions to save energy. Even higher frequency 4G and 5G have less range, and the towers are at street level, sometimes on top of buildings. The signal is directed towards users and can switch direction almost instantly. Focusing the signal in this way is known as beamforming and conserves energy. A dedicated phone antenna is needed to pick up the signal and direct signals to cell towers. The squares represent an antenna array on a phone. The lines are the wavefronts of the cell tower signal. A given wavefront reaches the antenna at different times. We want to get as much of the signal as possible, so more antennas the better. A phase shifter is used to delay the signal from the antenna array so that they can be added up constructively to form a signal which is then digitized. The phase shift is only for one frequency, but there is a bandwidth, so many frequencies are coming in at the same time. This causes beam squint, and the amount of beam squint is acceptable for 4G and some 5G. Beam squint really means we have lost information. The signal from millimeter wave 5G and 6G has a large bandwidth. So the delta F is really big and the beam squint is too much, which means the signal is really degraded, as you can see. So a new type of antenna design is needed. The diagram shows a digital antenna design. The signal from each antenna is digitized, so no information is lost. These digital signals are then added up to form the signal. The design from Beammwave B works well and crucially has low power usage, which is essential for mobile phones. This has been achieved not by using a new novel material, but through clever algorithms. It has taken more than 10 years to develop. This, I think, is the near future of mobile communication. Beammwave B holds an extensive list of patents, and as far as I know, no other company is developing a purely digital antenna. There are some global contracts that gives us confidence in their technology. There is Molex, an American electronics company, which is a subsidiary of Koch Industries. They plan to integrate digital antennas into a range of products. Koch Industries has an annual revenue of $125 billion per year. There's also a global Asian customer, probably Japanese. that wants to use these antennas for phones. There's also Nitto Denko, a Japanese corporation, who have an annual revenue of $60 million per year. They are developing an antenna together with Beamwave using a specialized material. There are also military applications, which could include high bandwidth secure battlefield communications, radar, and sensing. This company could be strategic for NATO and also the European Union. When will all of this manifest? No specific time frame has been given by the company, but I expect Beamwave B to make waves globally sometime in 2026. Thank you for watching the video.